This presentation is a discussion of security-enabled Linux, HTTP, and HTTPS. We go through each of these subjects, the best practice, the hardening, and the technical discussion. This presentation is prepared by Christopher Hill for ISA 4220, Server System Security. On this slide, I'll be discussing SC Linux. So, SC Linux stands for Security Enhanced Linux. It's a security feature in the Linux kernel and enabled by default. It provides more fine-grained access control compared to traditional file permission. A centralized policy determines which software can access what resource. For instance, a network service can be confined to a particular port, and Apache Web Server can be restricted to be enabled to connect to only the port 80 by default. It was developed by the US National Security Agency to protect computer systems from malicious, injurious, and tampering. So SE Linux is a new form of securing access to resources. So SE Linux was developed by NSA and a partner with the Red Hat to continue development and carry out integration of SE Linux into the Red Hat Enterprise Linux. It was not specific to Red Hat, however, and other Linux distribution and other operating systems have adopted SE Linux and similar framework. Also, you need to be very careful. SE Linux is not a firewall. A firewall controls the flow of traffic to and from a computer to the network. SE Linux can confine access of program within a computer and hence can be conceptually through an internal firewall between programs. Security works best when multiple layers are used and SE Linux is complementary to a firewall. So this is the summary about SE Linux. So you gotta remember that SE Linux is not a firewall. It's just complementary to a firewall. On this slide, I'll be talking about the best practice for SE Linux. First, you need to get the full list of SE Linux managed ports. By getting the full list of managed ports, you will be able to create rules. And those rules will help you monitor your systems. Second, you need to customize policy modules. SE Linux comes with standard policies. So and each system is different. So you need to customize your policies and minor modification to SE Linux policies can be made without modifying and recompiling the policy source by setting Boolean values for optional features. So it's very easy to modify policies for SE Linux. Third, you need to understand how SE Linux works. So without understanding how SE Linux works, you won't be able to configure it. So the first thing you need to do, you need to understand how it works, how to get the list of ports, and how to configure the policies. And fourth, don't use the default policy for packet dropping. using any default policies is really it's really not reliable because it makes your system vulnerable. So that's why you never want to use default policies. Always update your policies or modify them. Never use the default policies. And fifth, avoid flushing SC Linux rules. And sixth, avoid complicated rules. The best thing is to split them. When you have complicated rules, it becomes harder to manage. So this is why the best thing to do, always split them into small rules instead of having complicated ones. And seven, be strengthen visual rules. On this slide, I'll be talking about hardening for IC Linux. First, based on your requirements and goal defined in the security policy, one of the IC Linux mode has to be selected. Also, have a good understanding of booleans in order to get a working security policy. IC Linux boolean is a single string that changes how IC Linux reacts. When you toggle a boolean, it changes the active policy rule on the systems. So IC Linux support booleans to dynamically update the runtime policy. The value of these booleans can be persisted across reboots. You can use C search to display the consequences of a boolean, or to see if a boolean is available to allow certain statements. And third and final, monitor and analyze SC Linux behavior in order to effective rules. So this is, you need to monitor it, see how effective are the rules. So if you see that the rules are not really effective, make sure you update them. But without monitoring them, you won't know if a rule is working correctly or not. So always make sure the rules, you analyze the rules, and also always make sure the rules are updated if they're not working correctly. On this slide, I'll be discussing HTTP and HTTPS. HTTP stands for Hypertext Transfer Protocol. It is a system for transmitting and receiving information across server and the client. The server is the machine where your website code is placed, and the client is nothing but your web browser. HTTP manages the mutual understanding between the server and the client to exchange information or data successfully. The first HTTP had only one method called as GET, which would request a page from server, and the response was a HTML page. The latest version of HTTP defined 9 request methods. HTTPS, or Secure HTTP, some people may call it, is a combination of hypertext transfer protocol with SSL or TSL protocol. Now everything you communicate over HTTPS will be sent and received in an encrypted form, which add element of safety. When a client makes a request to the server responds by offering a list of encryption methods. When the client connects to a website via HTTPS, the website encrypts the session with a digital certificate, secure socket layer or SSL, use a cryptographic system that encrypts data with two keys, that is browser and server, each other Unicode, which are required to use for encryption for the rest of the talk. HTTPS is used in many situations such as login page for banking, forms, corporate login, and other applications which data need to be secured. These application server can be executed on Linux OS with Apache Server or on Windows with IIS. So on Linux, Apache Server is used. On Windows, we use IIS to handle HTTP and HTTPS. So what is the difference between HTTP and HTTPS? HTTP is unsecure and HTTPS is secured. HTTP use port 80 to communicate. HTTPS use port 443. And no certificate is required for HTTP. But for HTTPS, we need a SSL digital certificate. And no encryption in HTTP, but in HTTPS, data is encrypted before sending and receiving. On this slide, I'll be discussing the best practice for HTTP and HTTPS. Always use application to evaluate the web interface code error. So you need to always make sure that a website is working fine, especially for HTTPS, because for HTTPS the certificate might be expired or you can have issues with the certificate. So you need to always evaluate the web interface. Always make sure it's working correctly. So that's one of the way to make sure your HTTPS is working correctly. For HTTP, by just going to the website, you should be able to know if it is working fine or not. Second, you need to host the application on a secure server, because without a secure server, hackers can get into your server and have access to files, restricted files. So always make sure the firewall is on, and always have rules set up, and always always do a maintenance of your server. Always follow the maintenance. Always make sure everything is up to date, everything is updated. Always check the firewalls and do an internal audit. And lastly, make sure the application is tested before deployment. So always make sure, that's one of the best. That's one of the best advice you need to follow. Always test your application before deploying it, because before deploying it, you should be able to know if the HTTP or HTTPS is working correctly. So that's one of the best way to know if HTTP or HTTPS is working. Always test it before deploying it on the production server. On this slide, I'll be discussing hardening for HTTP and HTTPS. First, you need to always avoid using the non-secured version of web interface. Second, better use the HTTPS version. So you need to always make sure you use HTTPS, because HTTPS is encrypted, so it's way secure than HTTP. So, and especially if you processing especially if you're processing delicate data, always use HTTPS, so that way you know your data is safe. and no hacker can access it. Third, secure the application server. So by securing the application server, no one will have access to the HTTP or HTTPS data. Fourth, deny the folder browsing on the server from remote place. So by denying the folder browsing from a remote place, you're not putting yourself in danger of hackers getting through that connection and getting access to your folders. So always deny folder browsing from a remote place, because that way no one can access the server remotely. And fifth, always monitor the type of connection to the web interface. So by monitoring this, you are 100% safe that everything is going safely. The connection are working fine between the web interface and the server.